In this video, we shall look at decomposing rational functions into partial fractions. And rational functions are functions of the form p of x over q of x, where q over x is not the zero polynomial. Note that we are dealing with proper rational functions. And we shall look at 4 cases, and these cases will be determined by the nature of the factors of q of x or the denominator. So case 1 is where the denominator factors into distinct or unique linear factors. For example, 6x plus 5 over x plus 2 times x minus 1. X minus 1 and x plus 2 are linear factors, and they are distinct, they are unique. Or something like 3x plus 1 over x dx plus 5. X is a linear factor, x plus 5 is a linear factor. So this is case 1. And if we consider the first one, then you will get a over the first factor, x minus 1, plus b over x plus 2. So you decompose 6x plus 5 over x minus 1 by x plus 2. So note that you can express it as the sum of 2 fractions, the partial fractions, a, where a is a constant that you need to find, over x minus 1, plus b over x plus 2. When you go to case 2, the denominator has repeated linear factors. They are repeated. For example, 3x squared plus 2x plus 1 over x plus 1 times x minus 2. The distinguishing factor here is x minus 2, that is repeated. X minus 2 is linear, but it is repeated. Note that the others are just like case 1, but what makes this to be case 2 is x minus 2 squared, that is repeated. So again, this one will be the same as, almost like case 1, a over x plus b over x plus 1 plus, now here is the difference, c over x minus 2 plus d over x minus 2 squared. Okay? X minus 2 squared. And note x minus 2 is the one that is distinguishing this case 2 from case 1. Now, if you look at case 1 and case 2, the denominator has linear factors. When you go to case 3, the denominator deals with quadratic factors. And case 3, you have unique irreducible. Irreducible is you cannot factorize them further. So they are unique. Note that x is linear. What is important here to note is this factor, x squared plus 1. It is a quadratic factor that you cannot reduce in the set of real numbers. So this one will be a over x because x is linear plus, now here it's the difference, bx plus c. Note the numerator now, over x squared plus 1. Then you go to case 4, again the denominator, the factors are quadratic and they are irreducible. And for this particular case 4, they are repeated. Note, for example, x cubed plus x plus 2 over x times x squared plus 1 squared. This is the one that is distinguishing this one. x squared plus 1 is a quadratic factor that is irreducible and it is repeated. So this one will be the same as a over x plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 squared plus 1 squared. So those are the four cases, and what we need to do then is to decompose them into partial fractions. And to do this, we shall start with the first one, when the denominator factors into distinct unique linear factors, and we are interested with 6x plus 5 over x minus 1 plus 2. So we start with the first case 1, where we need to decompose 6x plus 5 over x minus 1 times x plus 2. We are saying that this can be decomposed as a over x minus 1 plus b over x plus 2. So our problem is to find a and b. Note that the right hand side can be written as a x plus 2 plus b x minus 1 over x minus 1 by x plus 2. And if you compare this left hand side with the right hand side, these two, you will notice that the denominator are the same, and therefore we can assume that the numerator 6x is congruent, or is the same as a x plus 2 plus b x minus 1, and this way you'll be able to find the values of a and b. So now we can do this. We can let x to be 1. If we let x to be 1, you will find that this will be 1 minus 1, which is 0. And therefore 0 and times b will make b explode. So if we let x to be 1, then we shall have 6 plus 5 is equals to 3a. 3a, because 1 plus 2 is 3, 3 times 3. Therefore we have 11 is equals to 3a, which means that a is the same as 11 over 3. Next, we want to eliminate a. This a. So to eliminate a, what we can do is we let x to be negative 2. If we let x to be negative 2, then we shall have negative 2 plus 2, which is 0, and 0 times a explodes a. So we shall have x as negative 2. The left hand side will be negative 12 plus 5 is equals to, now x is negative 2, so this will be negative 2, negative 1, that is negative 3a. And then we have 5 minus 12 is negative 7 is equals to negative 3b. Negative 3b, which means that b is the same as 7 over 3. 7 over 3. And therefore our fraction will be the same as a, which is 11 over 3 x minus 1 plus b, which is 7 over 3 x plus 2. So in other words, the fraction of the function x, 6x plus 5 over x minus 1 times x plus 2 has been decomposed into 11 over 3 x minus 1 plus 7 over 3 x plus 2. So that is case 1. That is case 1. That's how we can decompose the example we have here.